Our final example of just an abstract separable equation is let's solve the following. So let's solve, where did it go? Let's solve y prime is equal to y squared plus 1 times x squared plus 1. And let's make it an initial value problem. Here we want y of 0 to be 1. Okay, so again, that means that if x is 0, then y is 1. Right? It's like saying f of 0 is 1. So this is what we want to do. And this is separable, of course. Some of these you might have to work a little bit algebraically to check that they're separable, but they're separable. And so what we'll do is we'll replace y prime with dy dx. In fact, I'm going to cheat and do it here. So dy dx. And then we'll get all the y's on one side, all the x's on the other, and go from there. So we end up with 1 over y squared plus 1 dy is equal to x squared plus 1 dx. And then we'll integrate both sides. And then on the left side, we have to think about what's the integral of 1 over y squared plus 1. And it turns out that that is arctangent. So we get inverse tangent or arctangent of y. On the right side, we'll end up with 1/3 x cubed plus x plus c. And then if we want to solve for y, what that means is we're going to take the tangent of both sides of the equation. And we'll end up with y as tangent of 1/3 x cubed plus x plus c. Okay, and so that's this is one that's there's no way we guess that from the initial differential equation. Okay, some of the previous ones we could solve probably by guessing or at least figure out a solution, but there we go. And then the last thing that we need to do is incorporate our initial value. So we know that 1 is equal to y of 0. On the other hand, if we plug in 0 to our function, we're going to end up with tangent of c, because if x is 0, then the argument of tangent is just going to be c. And now we need to think about what's the value of tangent that we have to plug in to get 1, assuming that we're only going to talk about values, say, we can restrict the domain of tangent if we want. There's actually infinitely many solutions here, depending on where we're talking about. But let's just say that we're talking about between negative pi over 2 and pi over 2, which is often regarded as the domain of tangent, or at least kind of the canonical domain. So this is, it turns out, going to end up giving us c is pi over 4, because pi over 4 is the angle where tangent is 1, or it's the angle where sine and cosine are equal. And yeah, so pi over 4, that tells us that our equation is going to have the solution 1/3 y is tangent of 1/3 x cubed plus x plus pi over 4. Okay, and it turns out that that's the function satisfying this differential equation with this initial value.